Isaac Newton, the man who measured the universe. Before rockets touched the stars, before gravity had a name, there was a time when the universe was full of unanswered questions, mysteries that left even the greatest minds of the age baffled. But in a quiet corner of England, a boy would grow to challenge everything we thought we knew about motion, light, time, and space. His name was Isaac Newton. Today we step into the life of a man whose thoughts reshaped the very fabric of science. If you love stories of brilliance, mystery, and the boundless power of human curiosity, hit that subscribe button and follow us to the edge of knowledge itself. Chapter 1: A Fragile Beginning. Isaac Newton entered the world on Christmas Day 1642 in the rural hamlet of Woolsthorpe, Lincolnshire. Born prematurely and described as so small he could fit into a quart pot, few believed he would survive. His father, also named Isaac, had died 3 months earlier. When his mother, Hannah Eastcott, remarried, young Isaac was sent away to live with his grandmother, a decision that would leave emotional scars for life. This early abandonment planted seeds of solitude. Newton became a quiet, contemplative child. Rather than play with others, he built miniature mechanical devices like sundials and windmills, and scribbled notes into the wooden walls of his home. His loneliness fueled a hunger for understanding, a need to dissect the world around him piece by piece. Chapter 2: The Quiet Boy with a Restless Mind. Newton's formal schooling began at the King's School in Grantham. He wasn't particularly successful at first, more interested in building machines than memorizing Latin, but a quarrel with a classmate sparked something in him, a need to prove himself. He became intensely focused, rising to the top of his class. In 1661, he was admitted to Trinity College, Cambridge. At the time, the curriculum was still rooted in Aristotle's philosophies, but Newton, with access to modern thinkers like Galileo, Kepler, and Descartes, began reading voraciously on his own. He taught himself advanced mathematics, immersed himself in celestial mechanics, and kept notebooks filled with questions, many of which had never been asked before. Chapter 3: The Plague Year of Wonders. Just as Newton's intellectual journey was accelerating, disaster struck. In 1665, the Great Plague forced Cambridge to shut down. Newton returned home to Woolsthorpe, and instead of falling into despair, he dove into his work. What followed was nothing short of miraculous. A 2-year period known today as Newton's Annus Mirabilis, or Year of Wonders. He studied the motion of objects and began formulating what would later become his 3 laws of motion. He imagined a force that reached from Earth to the moon, the force we now call gravity. He used prisms to split light and realized that white light was not pure but a combination of colors. He invented the fundamentals of calculus years before Leibniz, and he designed the first working model of the reflecting telescope. All of this done in isolation before his 26th birthday. Chapter 4: A Universe Explained, Principia. By the mid-1680s, Newton had transformed his insights into a coherent vision of the physical universe. Encouraged by his friend Edmund Halley, he compiled his theories into a monumental work, Philosophiae Naturalis Principia Mathematica, published in 1687. It wasn't just a book, it was a revolution. In Principia, Newton laid out his 3 laws of motion: inertia, acceleration under force, and action-reaction. But more than that, he introduced the law of universal gravitation, proposing that every mass attracts every other mass in the universe with a force that decreases with the square of the distance between them. This elegant theory explained everything from falling apples to the orbits of planets. It brought the cosmos under mathematical control for the first time. The universe, once thought to be governed by divine mystery, was now described by rational laws, testable, predictable, and beautiful. Chapter 5: The Light Reveal. Opticks. Newton's curiosity didn't stop at motion. He turned his attention to light, a subject steeped in superstition and confusion. Through countless experiments in darkened rooms, he used prisms to reveal that white light could be split into a spectrum of colors. He concluded that light was composed of particles, and that color was a property of light itself, not something added by a medium. In 1704, he published Opticks, a groundbreaking book that not only challenged conventional theories, but laid the foundation for the modern science of optics. Alongside his theoretical work, Newton invented the reflecting telescope, which used mirrors instead of lenses to eliminate chromatic aberration, a problem plaguing previous designs. That same principle is still used in most modern telescopes today. Chapter 6: The Statesman and the Secret Thinker. In later life, Newton moved into public service. In 1696, he was appointed Warden of the Royal Mint and eventually became its master. There, he applied his scientific rigour to reform England's coinage system, tackling widespread counterfeiting and helping stabilise the economy. In 1703, Newton was elected President of the Royal Society and remained in the position for the rest of his life. In 1705, he was knighted by Queen Anne, becoming Sir Isaac Newton, one of the few scientists to receive such an honour in his own lifetime. But behind his powerful titles, Newton remained intensely private. He never married, was prone to emotional outbursts and carried long grudges. He feuded with other scientists, including Robert Hooke and later Leibniz, over credit for discoveries. In secret, he studied alchemy and biblical prophecy, convinced that hidden codes in scripture could reveal the future. In one letter, he even predicted the world would not end before 2060. Chapter 7: Legacy of a Giant. Sir Isaac Newton died in 1727 at the age of 84. He was buried with full honours at Westminster Abbey alongside England's kings and poets. On his tomb are the words, "Here lies that which was mortal of Isaac Newton." But his mind, his influence, those remain immortal. Newton didn't just change science, he changed how science is done. His laws laid the groundwork for mechanics, astronomy, engineering, and modern physics. His methodology, using observation, deduction, and mathematics, became the bedrock of the scientific revolution. He once said, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, whilst the great ocean of truth lay all undiscovered before me." Yet to the world, Newton was more than a boy on the shore. He was the one who mapped the stars above it. From a fragile child born under a winter sky to the giant who redefined time, light, and gravity, Isaac Newton proved that a single mind, fueled by curiosity, can unlock the secrets of the universe. If this story moved you, leave a like, share it with someone who believes in the power of knowledge, and don't forget to subscribe for more epic journeys into the lives of the world's greatest minds.